Hi friends, today we are going to discuss about how do we connect Java to a Cassandra database. For this, I have my cluster set up on a Linux machine where I can see the status of my nodes as. So basically I have a cluster with 3 nodes, out of which node 1 is up, node 3 is up, but node 2 is down. I connect to one of the nodes here so that I can see what are the tables in my database. So I have a key space called demo, and I'm going to connect to demo database, and I'm going to describe my key space so that I'll get to know that the key space was created with protocol as simple strategy for replication, and the replication factor being 3. Replication factor being 3 means every record that has been inserted into these tables have been replicated on 3 nodes. There is a table called users with following columns: last name, age, city, email, and first name, where last name being the primary key. I would like to check what are the contents of my table, and I'll do a select query on my SQL/SH, select star from users, and I see that I already have a record where the last name is John, age is 20, and city, email, and the first name as David. Now I would like to see how do I connect from my Java program to Cassandra database. So for this, I'll log into my Java ID. I'm using an Eclipse for the Linux machine. I have a very simple program called Cassandra with Java 1, where I have libraries, Cassandra related libraries associated here. So if I go and check to my build path, so I go to my project, right click, build path, configure build path, go to the libraries and see that I have imported the jars required to connect from Java to Cassandra, that is Cassandra 2.1.9 jar version. Using these libraries, we'll be able to connect to Cassandra database. We'll be able to manipulate the table, insert and update records, and we'll see those in a while. So I have a program here called Cassandra with Java 1, a very basic program with a main method. So I go here to cross check the IP addresses of my node. So I'll just come out of my SQL/SH and do a CCM node 1, node 2 status, and I see that 127.0.0.1.2.3 are the IP addresses of my node. Node 1 is up, node 2 is down, and node 3 is up again. So I go back to my Java program, where I create a reference variable of the cluster class. This is a class provided by the Java API which we use to connect to Cassandra, and a session instance. Now to instantiate the cluster reference variable, we use a builder design pattern to instantiate this object. So let's look what are we doing here. So we are using the class name cluster.builder, and then we are assigning a IP address to add contact point method, and then doing a build. So add contact point is nothing but it is the address of one of the node or a set of the nodes which the client driver would connect to while connecting to the cluster. Now we have created a cluster and mapped one of the IP addresses of the node. Now we need to connect to this cluster. For this we need a session object. it's kind of the similar HTTP session object which we use to connect to any web request. So to connect to a Cassandra cluster, we do a cluster.connect and then use the key space name. So we know that we have been using the demo key space, so we pass it on here as a parameter. Now to insert a query, to perform an insert query to our database user table called users, we do an insert query. So insert into users, and we define the content of the record for all the columns in the table, and then do a session.execute which will insert the query. Now we are now after inserting the record in the table, we want to do a select query to verify whether the record was inserted or not. So we are running the select query and then storing the result in a result set object, iterating over the result set, and then printing the content of our records. Similarly, now we did see that we inserted a user called Richa with age 27, and we want to update her age to 28. So we do run the update query in a similar fashion and then retrieve the results. Now if I want to run this query, run as Java application, since we have the code in our main method, so here we can see the results as before inserting the query, and then after we inserted we could see the record, and this was the record which was already there, which we checked at the start of our video, and then the age got updated from 27 to 28. To verify these results, whether it did it get inserted in our Cassandra database, we go and connect to one of the nodes and do SQLCH, and then do a use of key space and perform a select query, select star from users, and we can see that the record has been inserted and the age has been updated. So there you go. That's how we connect from Java to Cassandra. We now go over to the second part of this tutorial, which is called Cassandra with Java Part 2. Here we see few of the features of a cluster with add contact points and load balancing policies. So we create a class with the main method, and similarly as we did for the first program, we create a cluster session, and then to define, now I want my cluster to have contact points more than one of the nodes, so that when the client wants to connect to the cluster, it has multiple contact points, so that if one node is down, it will try to connect to the second one, and it will keep on trying to connect to all the addresses till the time it connects to at least one of the IP addresses. So it's kind of a fail-safe approach. So what I do is, the add contact points, it takes the collection of INET addresses. So I create the IP addresses and in form of INET address object to IP address 1, 2 and 3, and then add it to a collection like this by creating collection INET addresses, which is a collection as an array list which takes object data type as INET address. We add the node 1 and node 2. Since we know that node 2 is down, we're not going to connect to it. We go down and we create the cluster instance in a similar fashion using the builder pattern. The difference we see here is using the retry policy. The retry policy has been set to default retry policy.instance. This helps in case when we have timeouts during read or writes. So if there is a query, a read query or a write query, and our client driver was not able to connect to the node, say the node was unavailable, or if there was a timeout, it's gonna keep retrying for that amount of time. Now there is another very important concept called load balancing policy concept while connecting to a Cassandra cluster. Load balancing policy is nothing but it divides the tokens and distributes it in a balanced fashion across our nodes in the cluster. So say if I have a cluster with two data centers, data center with one which is in China and another data center 2 which is in USA. Say my client is in China and wants to connect to the cluster, so I would prefer that I have the settings in such a way that the client connects to one of the nodes in China, because that will be faster as it is nearer to the client. So for that I define with a parameter while creating the cluster object as with load balancing policy, and do a token aware policy which takes the object of DC aware round robin policy, which is deprecated now, but this is basically for our understanding. So this is the way it connects to the fastest node which responds to it. And then we connect to the key space. Key space is again demo. Here we are printing the nodes which we assigned in the cluster add contact points. So now I am again going to try to insert a record in my table. So I use a prepared statement, which is very common in Java, where we use the same class to insert or update in SQL database. The same we are using in CQL, although it's a part of datastacksdriver.core, but it's kind of performs the same way. So prepared statement is going to build my query before and then bind the variables later on. So this is kind of more performance sensitive, and I do an insert with records Bob Jones and then print whatever was inserted. Now I'm using a query builder, which is again another way of executing our queries in a Java program. This is more efficient because this avoids SQL injection, so our hackers cannot hack into our system by accessing the variables passed into the query, since we are using a builder pattern to form the query. So what we do is we do a query builder.select to key space, then the table name, and we frame our where clause in this fashion, that is .where, and we in the parentheses we pass querybuilder.eq, the column name and the value, and then we do a session.execute on the statement, and then we iterate over the results and display. So similarly we are going to use a query builder to do an update. So we update the last name. So we create an update query where we do a .set and we change the age, update the age from 35 to 36 for the last name Jones, and we execute our program. And then we do a delete query where again we are framing the where clause for last name Jones, and then we retrieve all the records which are there, and ultimately we close our cluster connection in the finally block. So I'm going to run my program and see what results I'm getting. So if I go to console, I can see that my client driver attempted to connect to these two nodes. It connected to it successfully, and then it inserted this record with age 35, and then it updated to 36. And then when I'm trying to read the records, I cannot find this Bob record because that has been deleted. So we successfully ran the insert, update and delete query from Java, and then close. I hope so. That's it, and I hope you enjoyed the tutorial. Thank you.